This lecture is on nephrons part 2, reabsorption. So last time I told you about how the capillaries form a tight ball called the glomerulus, which is surrounded by Bowman's capsule, and the blood flows through that capsule, and the big pieces, the blood cells and the blood proteins, remain in those capillaries, and then the other substances that are smaller pass through that filter, which is Bowman's capsule. And so we now have this new fluid called filtrate in the renal tubule. That's where I'm starting this lecture. So we have filtrate in the renal tubule. And the middle section of the renal tubule forms the loop of and the renal tubule is where reabsorption takes place. So reabsorption then reduces the volume of the filtrate by reabsorbing water. And it also returns. So reabsorption is what I'm talking about here when I say it. Reabsorption also returns various important substances. To the blood. The reabsorption of water is done by osmosis. So the water passively passes from the filtrate into the blood. However, reabsorption of glucose amino acids and salts is done by active transport. And I hope you remember that active transport requires ATP. That is to say, it requires energy. Therefore, there are many mitochondria to be found in the cells of the renal tubule. And if you think back to ANP1, you know why. It's this. I hope you remember that when our bodies make ATP, this is the process called cellular respiration, that most of the ATP that your body makes is made in the mitochondria. So that's then the process of aerobic respiration. I hope you remember that. So anyway, we have these mitochondria in our cells, and those cells make ATP. But when you have cells that need a lot of ATP, you will find a lot of mitochondria in those cells, and that is what you see in the cells of the renal tubule. In the renal tubule, you find lots and lots of mitochondria because the cells of the renal tubule use a lot of ATP. That is to say, they use a lot of energy in order to do this reabsorbing, this active reabsorbing of glucose and amino acids and salts, substances that our bodies want to keep, that we do not want to pass out of the body along with the urine, and so they are actively grabbed back out of the filtrate as it passes through the renal tubule. So they're sort of grabbed out of the filtrate and stuffed back into the blood. And that all takes energy, which of course in the body is in the form of ATP. So the renal tubule is lined with microvilli, so little teensy projections, basically, to increase, and again, think like a physiologist. When you see something like microvilli, the usual reason for it, then, is to increase surface area for reabsorption. Reabsorption takes a lot of reabsorption takes a lot of surface, basically, and because this can only take place at surfaces, and so therefore you're sort of actively making more surfaces by having the microvilli there. So now I'm going to do a drawing more complete than the last one that I drew of a nephron and what is going on, now that you have a better idea of the full process. You already know how this starts. So we have, here it is. I'll even put it here. So here then is the renal artery. And then here we have an arteriole, right? There it is. here we have the glomerulus. Here we have Bowman's capsule, right? Here we have the renal tubule. So here's the renal tubule, and again, leaving out a lot of detail, a lot of convolutions. This goes up. It forms the loop of Henle. It's still all the renal tubule. Here we are again. You should be familiar with this now. So all of this now is the renal tubule. And here we have a collecting duct, right? With other renal tubules feeding into it at various times. So here now we have a collecting duct. Urine there. From it flows into the renal pelvis. You are aware of all this. All right, so we have the filtrate. As we did before, the filtrate then is made up of stuff we want to keep and stuff we want to get rid of. You remember this, I hope. So here then we have the filtrate. This should be familiar to you. So what is going on? We have this other blood vessel right here. Here's what goes on. It's this. Okay, the blood from this arteriole forms this tightly bound up bunch of capillaries called the glomerulus. But remember what I said about how the blood cells and the blood proteins remain in the blood even as the other fluids get squished through. So we still have this blood here that has to go someplace. And you may notice that I drew this in. This is unusual for a capillary bed. The arteriole forms a capillary bed, and then it does not form into a venule. It reforms into an arteriole. So here we have an arteriole. This blood has not yet given up its oxygen. Okay, so here we have a new arteriole formed from the capillaries of the glomerulus. And now this is highly diagrammatic, but bear with me here. I'm just going to do it like this. But here we now have a capillary bed that does the stuff that capillary beds usually do. That is to say, you have oxygen-rich blood in this arteriole. This is still an arteriole here, okay? It forms a series of capillaries. I'm only going to draw them across here just for the sake of brevity. But here we have some highly diagrammatic capillaries, alrighty. Here we have some capillaries, which are, of course, smaller than the arteriole in real life. But here's what's going on. The blood in these capillaries is, of course, oxygen-rich, going in, which I am symbolizing with red. And then as it passes through these tissues in the usual way, it gives up its oxygen It takes on carbon dioxide. Here we are, the carbon dioxide is going in, all right, until finally you wind up with oxygen-poor blood in these capillaries. And these then flow into a venule. So you had an arteriole here. Okay, so this is arteriole like this. Arteriole with oxygen-rich blood. In the usual way, the oxygen is given up and you wind up then here with a venule with oxygen poor blood. So we had a capillary bed that did the usual thing that capillaries do, unlike in the glomerulus where capillaries form the glomerulus. Here you have a regular capillary bed that is formed, and you wind up with the blood flowing through the capillaries, giving up its oxygen, taking on the CO2 in the usual way, but at the same time, you also have the filtrate passing through all this area. Okay, so here's the filtrate. And this is happening throughout the renal tubule, but I don't have space for all of that. So the point is where the capillaries pass the renal tubule, then the good stuff goes in. Like so. And like so. The good stuff carries on. It still winds up going into the capillary beds until by the end there frankly isn't a whole lot of good stuff left. And meanwhile, waste products and things we're trying to get rid of are also flowing through the renal tubule, and as time goes on, there's less of the desirable stuff And what remains, therefore, is a greater proportion of the stuff we're trying to get rid of. So here is where the capillaries are not only giving off oxygen, they are also reabsorbing, the glucose and the salts and other things that our bodies want to keep, so that by the time the filtrate has been worked over by these capillaries, what you have left now is the urine. And the urine then, of course, flows into the collecting duct. Urine from other nephrons flows into the same collecting duct, and you wind up then